Okay, so here's a real-world application of sine, cosine, tangent, cotangent, cosecant, secant. Boy, isn't this awesome. It's real-world because I have someone fishing, so there you go. Just kidding. No real-world applications here. Sine. Sine of theta is opposite over hypotenuse, so we're going to go 5 over 13. Now if I ask you to find the reciprocal trig function, what was the reciprocal of sine? It starts with S, so this one starts with C. Good. Cosecant of theta is equal to, good, 13 over 5. Alright? This is all you're doing. Cosine of theta is 12, the adjacent side over 13. And the trig function related to that, yeah, its reciprocal is secant theta. And that is 13 over 12. Okay? Tangent is opposite over adjacent. 5 over 12. So adjacent over opposite would be 12 over 5. And that's really all I'm asking for right now for all of those trig functions. Okay, so we've put some of these trig functions in context. We've also put them in context. Now we're going to put them on the coordinate plane. So it really doesn't get that much harder, but I'm going to demonstrate a couple of them for you because there are a couple little tricks in there. This part of it we will spend the next few days actually expanding to work our way into graphs of trig functions, but probably not the direction that you think it's going. So just sit back, relax, and use regular old triangle trig for this one, alright? Okay, so we're going to find theta. To do this, we're going to turn this angle into a triangle. But first, let me give you a little bit of vocabulary. So, for a long time, the next couple chapters, unless we're talking about navigation, because they're completely screwy and do everything off of north, go figure, we're going to call this right side, this part of the x-axis, we're going to call that 0 degrees. And this is the initial side of the angle. The other side is called the terminal side of the angle. So we have the initial side lying flat on the x-axis, and we have the terminal side, the other one. Now the terminal side sort of rotates this way. It could go here, it could go here, it could go here, it could go here. It can even go down below the x-axis. But the angle you're talking about is from here going counterclockwise to wherever the terminal side is, right? This one's pretty easy because it's right there in quadrant 1. So let's just draw a line straight down to the x-axis to make a triangle. I'm going to claim that if we know this is the point 8, 3, that we actually know a couple sides of this triangle. So 8 is the x-coordinate. Ta-da! 3 is the y-coordinate. We've got the sides 8 and 3. We don't care about this other side necessarily, unless I change the directions and ask you to find all 6 trig functions. If I did that, you would use Pythagorean theorem, find this one, and then find me all of the ratios. Simplify them, get all the square roots out of the denominator. Okay? But for right now, I'm just looking for the theta. So do I want to use sine, cosine, or tangent? Tangent? Okay. So the tangent of theta is equal to the opposite over the adjacent. So 3 over 8. Excuse the lemon eating upstairs. Okay, solving for theta. Theta is equal to the inverse tangent of 3 over 8. Remember, you really want to not put decimals into your problem until the very last step. So we're going to leave this as 3 over 8 until you type it into your calculator. Okay, so this is going to be the last example. You're going to find theta if the terminal side passes through the point -4, -7. So the first thing you do is draw a quick sketch. You put -4, -7, and I mean really a sketch. I really just care which one's longer and what quadrant it's in. Draw it down here. This is the point, -4, -7. So initial side, terminal side, we're looking for theta. Where do you draw the triangle? So you could very well draw a triangle here and figure out the rest of the angles once you knew this one. I'm going to ask for all the stuff we're going to do later to just get in the habit of drawing from this point back either up or down to the x-axis. So just take this point and connect it to the x-axis. Here we go. So here's our triangle. I'm going to redraw it through here. So this angle in here is not theta. Theta is this whole thing. So I'm going to call this x right now. I mean, obviously they're related, but we're going to find x first. And then this side, well, its coordinate here is -4, right? But the length of that side, which is what I care about for geometry, is just 4. I'm going to treat that as just a +4. And treat this one, instead of -7, as just a +7. Now, if you were finding the 6 trig functions for this, you would have to use the positives and the negatives. Okay? You're finding the trig functions, you need those positives and negatives. The answers in quadrant 3 are different from quadrant 2 from quadrant 1, because different ones are negative. But if we're just finding theta, if we're solving for this angle, we just want positive values. Okay, so that's a right angle. Sine, cosine, or tangent? Hopefully tangent. The tangent of theta is equal to, okay, here's the angle. The opposite side is 7, and the side touching the angle, the adjacent side is 4. So opposite is 7 over 4. Theta is the inverse tangent of 7 over 4. Now I said theta, but I actually didn't mean it. I meant x. Give me a second. Tangent of x, and x is equal to this, and x is equal to, let's use degrees, 60.26 degrees. Okay, we've got x. That's just this little piece. To find theta, this whole thing, we take this much and add it to that little piece. So something plus 60.26, how much is this much of an angle? 180, right? 180 degrees. So 240.26 degrees, there's your theta.
Is it recording?
Yes. Okay, so this is going to be the last example. We're given a point